Hello, grade 10 learners. Our topic is on problem solving involving sequences. In today's lesson, we will be discussing how to differentiate arithmetic, harmonic, geometric, and Fibonacci sequences. Number 2, apply specific rule and solve problems on arithmetic, geometric, harmonic, and Fibonacci sequence. And number 3, explain the processes in solving problems involving sequences. Now let's start. Let us begin with this activity. Determine whether the given sequence is arithmetic, geometric, harmonic, or part of Fibonacci sequence. Then give the next term. For number 1, we have 5, 8, 11, 14. What type of sequence is this? This is an example of arithmetic sequence, and the next term is 17. This is an arithmetic sequence because it differs by the same constant, which is called the common difference, and that is positive 3. For number 2, we have 3, 5, 8, 13. What type of sequence is this? This is an example of Fibonacci sequence, wherein the succeeding terms are the sums of the two previous terms. So the next term is 21. For the next one, we have 1 over 9, 1 over 14, 1 over 19, and 1 over 24. What type of sequence is this? This is an example of harmonic sequence, in which the reciprocal of the terms form an arithmetic sequence. So the next term is 1 over 29. For the next sequence, we have 15, 75, 375, and 1875. What type of sequence is this? This is an example of geometric sequence. It is a sequence in which the term after the first term is obtained by multiplying a non-zero constant. On this case, we have the ratio or the common ratio is equal to positive 5. That is why if we're going to multiply 1875 by 5, the next term will be 9375. Let us deal with the first problem. Lisa loves walking as a form of exercise to stay healthy and fit. She spent 15 minutes on her first week of doing the routine. Each week thereafter, she added 5 minutes to her walking time. So to represent this problem, we need to complete the table. So for the first week, Lisa spent 15 minutes of walking time. If Lisa added 5 minutes after each week, how many walking time will she have on the second week? And that is obtained by 15 plus 5. So for the second week, she will spend 20 minutes. For the third, we have 20 plus 5, and that is 25. For the fourth, we have 25 plus 5, and that is 30. For the fifth, we have 30 plus 5, and that is 35. For the sixth week, we have 35 plus 5, and that is 40. For the seventh week, we have 40 plus 5, and that is 45. For the eighth week, we have 45 plus 5, and that is 50. For the ninth week, we have 50 plus 5, and that is 55. And for the 10th week, we have 55 plus 5, which is equal to 60 minutes. For question number 2, did you observe any pattern? How did you obtain the time values? So notice that each time value after the first week is obtained by adding 5 to the time value of its preceding week. So therefore, the pattern is by adding 5. So for question number 3, what kind of sequence is formed by the time values? Let us recall that Lisa's walking time formed the sequence 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Since each term after the first is obtained by constantly adding 5 to the preceding term, the sequence is called arithmetic sequence. For question number 4, what was Lisa's walking time on the 10th week? So the table shows that Lisa's walking time in the 10th week is 60 minutes. Recall that the time that Lisa spent while walking in the 10th week can also be found using the general formula for arithmetic sequence. And that is a sub n equals a sub 1 plus the quantity of n minus 1 times d. So on this case, we just need to identify the following. A sub 1 or the first term is 15, n or the number of terms is 10, and d or the common difference is 5. We just need to substitute all these values to the formula. So we have a sub 10 equals 15 plus the quantity of 10 minus 1 times 5. So we simplify what is inside the parenthesis. So we have 9. And then we multiply 9 times 5, and that is 45. And then we add it to 15. That is why a sub 10 is equal to 60. It means that Lisa spent 1 hour walking time. For question number 5, what should be Lisa's walking time on the 20th week? Again, we will be using the general formula for the arithmetic sequence, and then we identify the following. A sub 1 is 15, n is equal to 20, and d is equal to 5. We simply substitute all these values to the given formula, so we have a sub 20 is equal to 15 plus the quantity of 20 minus 1 times 5. Simplifying what is inside the parenthesis, we get 19. 19 times 5, it will give us 95, and then we add it to 15. So it means that the 20th week she will spend 110 minutes or 1 hour and 50 minutes walking time. For question number 6, what is the total number of minutes spent by Lisa in walking since week 1 to week 10? So the total number of time spent by Lisa from week 1 to week 10 of doing walking exercise can be found by simply adding the weekly time elapsed. So we just need to add all this number of minutes. So the sum is 375 minutes. But we can also find the total number of minutes by using this formula. S sub n equals n over 2 times the quantity of 2 times a sub 1 plus the quantity of n minus 1 times d. And then we identify a sub 1, which is 15, n is equal to 10, and d is equal to 5. By substituting all these values to the given formula, we have s sub 10 equals 10 over 2 times the quantity of 2 times 15 plus the quantity of 10 minus 1 times 5. And then we simplify. We have 10 over 2, which is 5, 2 times 15, which is 30, and 10 minus 1, which is 9. And then we multiply first the 9 times 5. It will give us 45. Simplifying what is inside the parentheses, it will give us 30 plus 45, and that is 75. And then we multiply it by 5, and the sum of the 10 terms is equal to 375. So it means that the total number of minutes spent by Lisa walking since week 1 to week 10 is 6 hours and 15 minutes. Let us deal with problem number 2. In a game, each player must relay the same message to two persons in a minute. Starting off with the first player, Jen, how long will the message be passed on to all other 254 individuals? So we begin by completing this table. So we have time in minutes, which is 0 to 10. And the number of persons, we have to begin with 1, which is Jen. So for the first minute, we must multiply 1 times 2 since each player must relay the same message to two persons in a minute. So for the first minute, we have 2. So for the second minute, we have 2 times 2, and that is 4. For the third minute, we have 4 times 2, and that is 8. For the fourth minute, we have 8 times 2, and that is 16. For the fifth minute, we have 16 times 2, and that is 32. For the sixth minute, we have 32 times 2, and that is 64. For the seventh minute, we have 64 times 2, and that is 128. For the eighth minute, we have 128 times 2, and that is 256. For the ninth minute, we have 256 times 2, and that is 512. And for the 10th minute, we have 512 times 2, and that is 1024. So for question number 2, we have to write the sequence formed by the number of persons who received the message in 10 minutes. And did you observe any pattern? Let us describe it. So based on the table under question number 1, the sequence form of the number of persons who received the message after every minute is 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. Notice that term after the first is found by multiplying a constant 2 to its preceding term. For question number 3, is the sequence formed arithmetic? If not, what do you think is the sequence and why? So the sequence 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024 is not an arithmetic sequence, since the difference between its two consecutive terms are not constant. This means that each term after the first is not found by simply adding the same non-zero constant to its preceding term. And in fact, as we mentioned above, each term after the first is determined by multiplying a non-zero constant, which is 2. So, in this case, this one is what we call geometric sequence. So, for question number 4, how many persons received the same message in 10th minute? So, as shown in the table, there are 1,024 individuals who received the message in the 10th minute. But we have to take note that this number can also be derived using the general formula for geometric sequence, which is a sub n equals a sub 1 times r raised to n minus 1. We just simply identify the following. The first term is 2, the n or number of terms is 10, and the common ratio is positive 2. We just simply substitute all these values to the formula. We have a sub 10 equals 2 times 2 raised to 10 minus 1. Performing the operation on the exponents, we have 10 minus 1, which is 9. And then we have 2 raised to 9, and that is 512. And then multiply it to 2. It means that the total number of persons received the same message on the 10th minute is 1024. So for question number 5, how long does the message reach 254 persons from Jen? So the number of minutes needed to let 254 individuals know the message can be determined by using different rule for geometric series. And that is S sub n equals a sub 1 times the quantity of 1 minus r raised to n all over 1 minus r. Then we simply identify the first term, which is 2, the common ratio, which is 2, and the sum of the terms is 254. Substituting all these values to the formula, we have 254 equals 2 times the quantity of 1 minus 2 raised to n all over 1 minus 2. And then we distribute 2, 2 times 1, and 2 times negative 2 raised to n, and also we simplify 1 minus 2, and that will give us 2 minus 4 raised to n all over negative 1. And then we cross multiply, so we have negative 254 equals 2 minus 4 raised to n. And then we transfer 2 on the left side of the equation, and that will give us negative 256 equals negative 4 raised to n. And then we're going to divide both sides by negative. So it will give us positive 256 equals 4 raised to n. Now we're going to factor 4 raised to n, and that will give us 2 times 2 raised to n. Then we divide both sides by 2, and that will give us 128 equals 2 raised to n. We are going to express 128 to exponential form with the base 2 to have the same base from both sides. So that will give us 2 raised to 7 equals 2 raised to n. By simply equating the exponents, the value of n is equal to 7. So therefore, it will take 7 minutes to reach 254 from Jen. Now let us deal with problem number 3. Lina bought 1 kilogram of ground beef for breakfast. To make bola bola out of it, she also needs 1/2 kilogram of flour, 1/3 kilogram of potato, 1/4 kilogram of carrot, and 1/5 kilogram of onion. So we will be answering the following questions. So for the first one, write the sequence formed by the different ingredients. We have the sequence formed is 1, 1/2, 1/3, 1/4, and 1/5. For question number 2, is the sequence arithmetic? And we need to justify. So if the sequence is arithmetic, we have to take note that the differences between any two consecutive terms must be common. Now let us check. So we will be using here the second term and the first term for the right side, for the left side of the equation, and the second term and the third term for the left side of the equation. So we need to subtract here 1/2 minus 1. Is it equal to 1/3 minus 1/2? So we simplify 1/2 minus 1, and that is 1/2. 1/3 minus 1/2, and that is negative 1/6. So, since the differences are not equal, the sequence is not arithmetic. Now, for the third question, is the sequence geometric? Let us also justify that. So, for the sequence to be geometric, we have to remember that the ratios between any two consecutive terms must be equal. So, we will be using here again the second term over the first term equals the third term over the second term. We equate the ratios of any two consecutive terms. So, are they equal? So, we just need to copy the numerator and then get the reciprocal of the denominator. Copy 1/3 and then get the reciprocal of 1/2, and that is 2/1. And then we simplify 1 times 1 is 1, 2 times 1 is 2. So for the left side of the equation, the result is 1/2. For the right side of the equation, we have 1 times 2, which is 2, and 3 times 1, which is 3. So, as we can see, since the ratios are unequal, the sequences is not geometric sequence. Now, for question number 4, we get the reciprocal of each term in the sequence. So, the sequences is 1, 1/2, 1/3, 1/4, 1/5. And the reciprocals are simplified into 1, 2, 3, 4, 5. For question number 5, what sequence is formed by the reciprocals? So, we have 1, 2, 3, 4, 5. These are the sequence, terms of the sequence formed by the reciprocals. So this is an example of arithmetic sequence. For question number 6, if the pattern continues, what do you think is the 20th term of the original sequence? So this will be the representation. So as you can see, the 20th term is 1/20. Remember that this one is an example of harmonic sequence, since this is the sequence formed by the reciprocals of the terms of an arithmetic sequence. So therefore, the 20th term in the sequence is 1/20. Let us deal with problem number 4. Ben digs 10 holes for his marble collection. Out of curiosity, his cousin Alan seeks for them and finds out how Ben has arranged his marbles. One marble is in the first hole, one marble is in the second, two marbles is in the third, three marbles on the fourth, five marbles on the fifth, eight on the sixth, and so on. So we will answer the following questions. Now, for the first problem, write down the sequence. So the number of Ben's marble on the holes from the sequence is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. Now, for question number 2, is the sequence arithmetic or is it geometric? Now, to see if the sequence formed is arithmetic, check if the differences between two consecutive terms are the same or common. So we need to subtract the second and the first, and that is 1 minus 1, which is 0. The second and the third and the second, which is 2 minus 1, and that is 1. So here, the fourth and the third, which is 3 minus 2, which is 1. And here, the fifth and the fourth, which is 5 minus 3, which is 0. So since the differences of any two consecutive terms are different, then we can say that this is not arithmetic. And now, to check if the given sequence is geometric, simplify and get the ratios of two consecutive terms of the sequence. So we have here the second and the first term, which is 1 divided 1 equals 1. The second and the third and the second, I mean, is 2 over 1, which is 2. The fourth and the third term, which is 3 over 2, which is equal to 1.5. Since the ratios are not equal, then we can say that this is also not geometric sequence. Now, for question number 3, check if the sequence is harmonic. So, on this case, the sequence is harmonic if the reciprocals of the terms form an arithmetic sequence. Now, we get the reciprocals of the terms. We get the following, which is 1, 1, 1 half, 1 third, 1 over 5, 1 over 8, 1 over 13, 1 over 21, 1 over 34, and 1 over 55. By examining and comparing the differences between any two terms of the reciprocals, observe that the difference of the first two terms and the third and the second terms are not equal. That will simply mean that this sequence is not harmonic sequence. Okay, for the fourth question, add two consecutive terms of the sequence. What do you notice? So in here, to add any two consecutive terms of the sequence, that would be the results. So we have the following. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 12, 13 plus 21 is 34, 21 plus 34 is equal to 55. So we have noticed that the sums are also the consecutive terms of the sequence. Now, for question number 5, how do you relate the term and its two preceding terms? So, the term is simply the sum of the two terms that precede it. So, for number 6, if the pattern continues, what do you think is the next three terms? So, we just need the last two terms on the sequence, which is 34 and 55. We simply add that. 34 plus 55 is 89, and then we're going to add 89 to 55, and that is 144. 89 plus 144 is equal to 233. So it means that the next three terms are 89, 144, and 233. Now let's try doing this. A stack of oranges has 12 layers with 144 oranges on the bottom layer. There are 121 oranges on the second layer and 100 oranges on the third layer. If the pattern continues, how many oranges are there in the ninth layer? Is it A9, B13, C16, or D20? Now for the next problem, suppose Maria has to eat one kind of fruit on the first day of January, three kinds on the second, five kinds on the third day, and so on. How many kinds of fruit will she need until the 10th day? Is it A, 75, B, 100, C, 125, or D, 150? Now for the last problem, Basil harvested the fish he managed to grow in the fish pond. He got one bucket during the first hour, another one bucket on the second hour, two buckets on the third, three buckets on the fourth, and so on. How many buckets of fish were harvested if he spent 8 hours in harvesting? So is it A 13, B 21, C 34, or D 54? So that would be all for today, guys. Until our next session, thank you and enjoy learning.